Hi, everybody. So I'm going to be talking about Kubernetes and kind of a little bit about how Google has learned from using container technology over the last 10 years or so. So as kind of an introduction to myself, I'm Ian Lewis. I'm a developer advocate at Google. I work on the Google Cloud Platform team. So I'm also based in Tokyo. So I'm kind of often covering APAC, places like in Seoul and Taipei and places like that, as well as Japan. So you can follow me on social media if you're into that sort of thing. I'm Ian M. Lewis at Twitter. So today I want to talk about several things. So here's the agenda for today. The agenda is basically I'm going to be talking a little bit about kind of giving a refresher about how we do things today, how applications pre-containers worked, and then kind of contrasting them or comparing them to how to use containers or container technology. And then after that, I'm going to talk a little bit about Kubernetes and how that works, and then kind of wrap up and talk about kind of future direction and services and things like that you can build on top of Kubernetes. So first, I want to talk about current practice. So current practice is kind of how people did things pre-containers, like before using containers. So a lot of people have a kind of a setup that looks something like this. Like a lot of web applications, this is kind of a typical architecture for a web application. So you might have several web servers running, and those are connected to a caching tier and maybe a database. And you might have some sort of like back-end batch processing as well. So this is kind of a fairly typical setup. But how do you deploy this kind of thing? So what a lot of people did was used shared machines. And shared machines is basically like running your application on bare metal or running different applications on bare metal on the same machine. So what this is, but there's a number of problems with this. Like you don't have a whole lot of isolation between the processes. Like if one uses a lot of CPU, it can steal the CPU from other processes, and they'll run slower. And so you have kind of performance issues. There's also no kind of name spacing, so you can't really separate them into different logical groupings. They also have a common set of libraries that they use. So like each of the applications are using the same set of libraries. So if each of them have different, more complex dependencies, then you can have issues all running them all on the same hardware or on the same OS using the same set of libraries. And because of that, they're very highly coupled to the OS that they're running on. So when you build an application and you're deploying it this way, it's very easy to rely on the features of the OS or the types of things that are required or that the OS provides for you, rather than making it less coupled and making it easier to move around to different types of OSs or hardware. So people started using virtual machines to kind of help solve this problem. And this is what's been popular for a number of years. So this gives you some isolation. Each of the applications are running in a separate virtual machine, and that allows you to separate things like CPU and memory, and so that they can't steal resources from each other. But it's very inefficient. So you have a full OS running inside of a VM. So you have the issue of the VM actually having to, taking CPU resources itself for the guest OS. It also uses memory and things like that. And it's also, more importantly, very hard to start and stop. Like it takes, on the order of tens of seconds to start up machines sometimes. And so scaling applications up and down becomes a very difficult problem when you're using VMs. These are also very highly coupled to the guest OS, so you still have some of the same problems that you had with shared machines as well. And then it's just very hard to manage. You have lots and lots of these VMs running, and they all have different OSs, and you have to manage the OSs and upgrade the OSs and do things like that. And so it can be very difficult because you have to upgrade each and every one of them and manage each and every one of them. So this is a number of problems that I've outlined, but you have other problems, like how do you deploy your application? How do you set up the servers? Once you have an OS, you still have to install the applications and the libraries and stuff. So how do you do that? Do you use Chef? Like Puppet, Ansible, these are solutions that are great, but they require a lot to work with them. You have to create the scripts to install them and to install the applications that you need, and so it can be very cumbersome to use these apps. But you also need to think about things like versioning. How do you upgrade your application once you've deployed it? You can use things like Puppet and Ansible for that type of thing, but they're kind of overkill. You can also use applications like Capistrano or Fabric or something like that to update your apps. But those are cumbersome as well, and you have to write the scripts. And then you have to think about deployment. Like, how do you deploy your testing environments, your staging environments, your production environments? You want to make your testing and staging environments as close to your production environment as possible, but you don't want your staging and production environments to kind of step on each other's toes and take resources from one another. And so managing and making sure that both of these environments are similar enough that you can properly test your applications is very difficult. So these are not very easy to solve, and it can be very cumbersome to deploy these kind of apps using technologies pre-containers. So what are containers, and how are they good, and how are they going to solve these problems? So I want to take a little bit of a step back and talk a little bit about the history of containers and why we think that they're the future. But basically, at Google, we've been using containers for a very long time, but there's a number of other technologies. So Google is very well known for big data, basically having lots of data and processing lots of data. And we've developed a number of solutions to our unique problems to scale our applications. And so I think most people have heard about things like MapReduce or Bigtable, the type of database and data processing library or applications that we've created at Google. And we've also created things like Colossus and Dremel to also manage big data. And these have all been released as white papers, but the actual source code is kind of proprietary and works only at Google. But based on those white papers, people have developed OSS open source applications or implementations of that, and have created entire ecosystems outside of Google. So Google's known for big data, but what Google's not quite as well known for is managing the actual applications at scale. So we run big databases, but we also have to handle lots of traffic and handle the applications running. So one of the ways that we deploy these applications is using a system called Borg within Google. So Google has recently published a white paper on this as well. But Borg is also a very proprietary system, and it's very tied to our data centers, and it's a very old system, so it's very cumbersome to use, and it's not very fun to use. So we wanted to build something, an open source application that would help with that. But basically, we've been using containers for a very long time at Google, and basically, everything at Google runs in containers. So all of our apps, Gmail, Google Search, all of our indexing applications, all of that runs in containers, our databases as well. And so we actually start about 2 billion containers a week at Google. So we have quite a bit of containers running at Google. So we have quite a lot of experience with containers. And containers are basically look like this. So to compare and contrast, this is you can see that containers actually encapsulate the applications and their libraries and dependencies, but they all run on a shared kernel. So they run like regular processes. And so this is good because this allows you to start and stop applications at about the same speed that you start and stop regular processes on your computer. And so that makes things like scaling up and down your application very, very quick, and starting and stopping your applications, upgrading your applications very quick. So that solves a lot of problems with scalability and stability of your application. But it also gives you the same sort of isolation that you can get from VMs. So things like CPU and memory can be isolated, and so that each of the applications don't step on each other's toes. So resource isolation, you also get ease of deployment. So it's much easier to package and deploy these applications because you don't have to have an entire OS inside of it. So containers just kind of simplify the issue of deployment and running your applications. And at a high level, we at Google see containers as a kind of balance between infrastructure as a service and platform as a service. So infrastructure as a service you can think of as kind of like regular VMs or regular bare metal hardware. So the infrastructure as a service gives you a lot of flexibility. You can install pretty much any type of application you want on it, but the applications are not very agile. They're not very hard, or they're very hard to manage the applications. Installing things on the servers is not easy, and so kind of coordinating those servers is very hard. So it's not very agile. But on the other end of the spectrum, you have platform as a service, and deploying your applications is very easy on platform as a service. But you can't install anything you want. You're limited to the APIs that are available for that platform. And so that's very agile, but it's not very flexible. So we see the containers as being something that that fit right in the middle of that. So you can install pretty much anything you want on the containers and run anything you want, but you also get a little bit easier deployment. So your applications can be packaged and deployed much easier than, say, on a virtual machine or on a one-off basis on a virtual machine. But we see containers as a whole new kind of way of running applications. It's very different from what we've been doing before. So it can be very difficult to kind of reason about it when you're not used to that way of thinking. So there's many things that you need to learn when you're in using containers. So things like how to make your containers, your deployment fast, have performance, and things like reliability, and making sure that your service has has high quality. These can be very difficult things to manage. So there's kind of, we've solved a lot of problems, but we have and things will get easier, but there's still things that you need to learn, and so there's kind of some new problems here. So containers are great, but in order to help solve the issues that arise when you start using containers, we've created an open source application called Kubernetes. And Kubernetes is a very difficult to pronounce name, but it's basically Greek for helmsman. So it's something that kind of drives a ship. So Kubernetes is a cluster orchestrator. It's a way of running containers in a cluster in many machines, over many machines, and scheduling where those applications run on the machines. So it's very geared towards containers, running containers, and it supports multiple cloud and bare metal environments. So you can run it on things like Google Cloud Platform, or run it on AWS, or run it on whatever cloud platform that you want to run it on. But it's inspired and informed by our experience at Google running containers. We've had a lot of experience running containers, and so we've tried to incorporate that knowledge into the development of Kubernetes. So Kubernetes, being an open source project, has a community around it that's building. So right now, I think we have, over 500, it's about 525 contributors to the project, as well as having over 10,000 GitHub stars. I think it's the most popular project related to cluster organization on GitHub. We also are working with a lot of partners outside of Google to help develop Kubernetes and develop solutions around Kubernetes. So companies like CoreOS, companies like Red Hat and Mesosphere are developing solutions using Kubernetes. So that's kind of an introduction to Kubernetes, but what about the technical details? Like, how does Kubernetes actually work, and what are the kind of concepts to Kubernetes? So Kubernetes introduces like a few new concepts to that Kubernetes implements and that you can use in Kubernetes. One of those concepts is a pod. A pod is essentially a group of containers that will run together on the same physical host. So we use this particular pattern a lot at Google within our own container deployments. And what this does is it actually allows you to create a single pod that has multiple containers running in it. So think of a kind of a machine that has multiple processes running in it. And it gets a single IP address, and you can also share mounted volumes. And each of the applications, or each of the containers within the pod can talk to each other on localhost. So it's very easy to do service discovery this way. You don't have to have any kind of service discovery. You can just talk to each other on localhost. So this makes it very easy to create kind of composable applications that are very small and have a very small bug surface area, if you would say. This particular, there's an example here where you have a web server that serves up some content, and you have a content puller or a file puller that will update the content from your, maybe your Git repository or whatever. It can download the files and save them on a shared volume, and then the web server can then serve the updated content. So each of these can be composed individually and created individually. So you can actually use maybe this file puller with another application that's not a web server, maybe something completely different. Another concept that is in Kubernetes is volumes, and volumes are very similar to Docker volumes. So if you're familiar with Docker, then this should be very familiar to you. You can basically create volumes and attach them to your pods or your containers. And these, we have a number of different types of backends for these type of volume mounts. So you can mount things from persistent disks on cloud services like Google Cloud Platform, persistent disks, or AWS block storage. Or you can mount other things like a Git repository or a GlusterFS volume or a NFS volume. So like network disks also work. You can also create labels for your application. So labels are a kind of way of attaching a name or a value to your, or key value pairs to your pods. And this allows you to do things later like select a certain set of pods for different purposes, like upgrading them or setting up services or things like that. So you might have, here's an example, you might have an application that has 4 pods running and they each have these labels, but then you can select them later. So say like if you select using the app equals my app, like a selector using this way, then you'll get all of your pods back because they all have the same label. But then you can add a more fine-grained selector with the role. And in that case, here it's FE, so that means front end. And so that'll only get your front end pods. And then you can do the same thing for back end pods with a different role. And you can also select based on another label. So say in this case, phase, like production or test. So that's kind of an easy way to kind of select them, and there's a number of ways that, or a number of things you can do with that, like select specific services or specific types of applications. The next concept I want to talk about is replication controllers. So replication controllers are a concept that, or a part of Kubernetes that allows you to specify a group of pods. So you can create a group of pods that will have a certain number and a certain image. And what the replication controller will do, so you'll create a replication controller, and what that'll do is create the pods that you've specified in the replication controller. So here I have an API server, so I might say, here's my replication controller for my API server, and I want to have 4 instances of it running. And say, maybe you have 4 instances of it running, but one of the instances crashes. So in that case, the replication controller will periodically checks to make sure how to see how many of your instances of your application is running. And it will see that there are 3 running if one of them is crashed. And then, so it knows that it needs to have 4, so it will actually create a new one, add one in order to make it go back to 4, and then verify to make sure that it's got the right number. So it always keeps the right number of instances running for your application. So this helps things, this is kind of a self-healing type of feature. The next concept that I want to talk about is services. So within Kubernetes, you can compose applications into a service. So say you've created a replication controller and it's your API server and you've got 4 pods running. In this case, maybe 3 pods. But then you have 3 pods, but how do you connect to that service in such a way that it's like load balanced, or that it's, how do you do discovery to make sure, to figure out where this particular containers or pods are running? You can create a service which gets a virtual IP, and that virtual IP, if you connect to it, will, it's a virtual IP and port. So if you connect to that virtual IP and port, it'll actually load balance and connect back to one of your pods. So in this case, I have 3 pods running, but then I can create a single IP and port that I can connect to that will allow me to connect to my service and load balance across all of my individual pods. So this is great when I want to create a service that anybody can have or anybody can connect to on a single IP and a port. but have any number of pods running, so I can scale up and down my application without the clients or without the client applications needing to know how many pods I'm running and where they are and things like that. So services are also composed using labels. So these also use the label feature. So when you create something like a replication controller, you can assign a particular label to all of the pods within a particular replication controller, and then you can select all those pods using that label for your service. So all of these features kind of interoperate and work together to allow you to develop services. So once you've done that, you can Kubernetes will allow you to create replication controllers and services. So you don't really need to think about where your application is running or where the individual applications are running within your cluster. Let's say you have 5 individual machines that you're running. So each of these machines might have a set of CPU or RAM that is available for your application to use. But what you do is you don't run it on a specific machine. You will tell Kubernetes, hey, I want to run 3 instances of my web server. So say this is my web server, these are my web servers, and I tell it to run 3. It will run it somewhere in the cluster, and you don't have to think about it. It will schedule it to run in the right place. And so once you can do that, you can actually start running multiple different types of applications together within the same cluster. So say I have my web application, which runs and uses a lot of CPU, but not very much memory. I can run that kind of alongside my cache and database services that use a lot of memory, but maybe not as much CPU. And so in this way, you can kind of balance the use of your resources and use the resources much more efficiently. So I've got kind of a lot of time left, but I'm going to kind of wrap up and kind of talk about the kind of future direction of Kubernetes and the kind of long-term vision for the project. So the current status is that we've released version 1.0 of Kubernetes recently, and so we think that this is our production-ready version of Kubernetes, so you can use it in production, and it's stable enough for you to use it for real-world purposes. But we envision it as being not just an open source project, but as a way for people to develop their own kind of services on top of it. So one of the services that we've offered is a service called Container Engine, which is, I'll talk about in a little bit, which is basically a hosted version of Kubernetes that you don't have to install on your own machines. But a number of other providers have started working on projects of their own. So there's some platform as a service type of solutions built by Red Hat. So like Red Hat OpenShift, I think, is on there. And but there are also some other like kind of distributions or server distributions, like CoreOS's Tectonic and Mirantis's solution using OpenStack and so there's several other kind of solutions that are being built on top of Kubernetes that build more composable kind of services. And we're starting to work towards releasing the version 1.1 of Kubernetes, and we're thinking about releasing new versions about every 3 to 4 weeks. So what's our goal with this? And our goal is basically to kind of shake things up. We think that we at Google have been working on using containers for a very long time. And we think that that's the best way for people to deploy applications. Basically, for the reasons that I've mentioned, we think it's much more efficient, it's easier to deploy, that sort of thing. And so we want other people to start using containers as well. This more closely matches our infrastructure, and it makes it easier for us to work with people outside of Google as well. And people have been using VMs for a really long time, so we want to kind of get people to understand and work with containers more. So we've been using it for a long time, and we want to also share our experience and our expertise with other people outside of Google as well. But this is still kind of a new concept outside of Google, and so we really want to see how people outside of Google as well start using containers and incorporate their feedback into the development of Kubernetes. So to talk about a little bit about services based on Kubernetes, one of the services is the one that we provide, which is called Container Engine. And Container Engine is essentially just Kubernetes, but hosted on Google Cloud Platform. So you can just, with one command, you can create a cluster and then use that cluster immediately. You don't have to install all the pieces and get all the networking and things like that working. So it's very easy to get started using it. And so Container Engine is essentially just a hosted version of Kubernetes, which you can find out more about at cloud.google.com. We recently released it as a GA product, so it's kind of like our version 1.0 release. So we think it's usable for people in production, and we provide an SLA for it. So we'll actually pay you money back if it goes down too often. And so it's got kind of a unique pricing. It's built on top of Container Engine, our VM solution. So it basically up to 5 nodes. It will only cost there's no added cost, so it only works, or it only costs the amount that the VMs cost themselves. So thanks a lot. I think I can probably take some questions at the end here. Yeah, thanks you for listening, and I hope you guys got something out of that.